Hey, let me just get to the top of the screen. Okay, all of you just switch your mics off because otherwise can be a disturbance. All right, today we are going to do the 2019 problems, which we didn't finish, and we'll do a few 2018 round 2 problems. I'm going to start with problem number 11. I think this is where we stopped, 2019. And I trust that all of you have gone through the problems. You had it for a day or two, so hopefully you went through these problems before coming here. As I say many times, there's no point in looking at getting the answer and getting the solution immediately afterwards. You don't learn anything that way, so it's just a waste of time. All right, so the first problem, as you can see, it says that you've got a straight line whose equation is given as x plus 3y plus 80 equals 0. And this line is reflected. You've got another line, y equals mx plus b, and that is the reflection of this line in the x-axis. Now, what does this mean? Let's just first understand what we are saying here. So I've got an xy frame. Let me just change the colors to black. And you have this line. Now, the line is normally given as y equals mx plus c, but it's given like this. This is also an alternative way of writing the line. In fact, this is a nice way of writing it because you can draw the graph very quickly. All you have to do is to just substitute x equals 0. Substitute x equals 0, then you get 3y equals negative 80. So when x equals 0, 3y equals negative 80. So negative 80 over 3y is the y-intercept. X is 0, and then you calculate something. And then likewise, when y is 0, x is negative 80. So when y is 0, all along this line here, so you have that. So you have 2 points on this line, which means I can draw the graph of the straight line. Okay, so what's going on here? I'm sorry, I'm having some problems. It's asking me to select a camera. Okay, somehow I got through to that. What the heck is going on here? Okay, I've selected a camera. Sorry about that. There was some hitch on this thing. So you've got a straight line that goes through these points. This is x plus 3y equals minus 80. And you've got this line is actually the reflection of another line. And y equals mx plus b, you're reflecting this thing across the x-axis. What does this mean? I'm sorry, I'm struggling to... Uh, just give me a little bit of time, please. There's something is going on here. I can't understand it. I know, is your camera? It's insisting that I select a camera. Just one moment. I'm sorry. I've never had this problem before, and I'm going to stop the share. And I'm going to remove my camera. Oh gosh. Sorry about this. There's something that I cannot understand about this. All right. Let me not draw anything. Okay, I'm going to just look at the pictures here, the solution. Sorry about this. So the question says y equals mx plus b is a reflection of a line x plus 3y plus 80 equals 0. And we've drawn this line. This is x plus 3y plus 80 equals 0, as you can see. And this line here is reflected across the x-axis. You can see the x-axis, right? So what does this mean? If I take any point on the line, as you can see, I'm reflecting it across the x-axis. So that point goes to this point like this. And you will see that the x value still remains the same, right? But the y value, it is negated. This y now becomes minus y. So this is actually x comma negative y. So the point on this new line is, if xy is a point on the old line, then x negative y is a point on the new line. What does this mean? It means that the equation of this line here was originally this. The equation of the new line will have to be, you replace y by negative y, because the new coordinates satisfy the equation of this line. So it has to be, the y will have to be replaced by negative y. The moment you do that, then you got the equation of the reflected line, and that is what we are looking for. But the equation of the reflected line is given as y equals mx plus b. So you have to rewrite this thing here in the form of y equals mx plus b. So when you make y the subject, right, you'll see that you get this, and that is your mx plus b. So the value of m is 1/3, and the value of b is 80/3. And the question was actually find m plus b. That was the question, right? If you go back to the question, that is the question. So you know what m is, what b is, substitute, and the answer is 27. Okay. Okay, now this is quite useful, that I'm looking at my own solutions and I'm explaining it. So we can do it like that, because if I can write, this allows me to write, then I will do so. Okay, let's get on to the next problem. The next problem is, you got a picture of a circle and two rectangles, as you can see. All right, and they are congruent rectangles. That means they are identical. They have the same length and the same breadth. Now, the area of a rectangle is 12. So the area of each of the rectangles, they are congruent. In other words, they are identical. area of each of the rectangles is 12, and the perimeter, that means if you add up all the four sides, right, is 14. Then the question is, if the circumference of the circle is n pi, what is n? So what do we need to do? We need to calculate the circumference of the circle. Now, here is a circle. To calculate the circumference of the circle, you need to know its radius. Now, no radii are given here. We don't even know where the center is. So how do you find the radius? Well, we can't find the radius, but we can find the diameter. Now, why is that so? The reason why we can find the diameter is that, you see, this is a rectangle, so this angle here is 90 degrees. And it's well known that if you got an angle 90 degrees like this on a circle, then a diameter subtends 90 degrees. I don't know whether the grade 10s have done that, but I think I'm just going to maybe I should explain that. So I'm saying it's a well-known fact that once again, it's not allowing me to do this. Okay. A well-known fact that if you have a circle, okay, it's the other way around. If you have a circle and if you draw the diameter, the line that goes through the center of the circle, then if I take the two endpoints together with a point, any point on the circumference, the two endpoints together with any point on the circumference, then those 3 points will give you a triangle. Sorry, that point was not on the circumference. If I take any point, the nice thing about this is that the angle that is formed at the circumference is always a right angle, you see. But as long as you got the diameter, as long as you do this construction with the diameter. So this angle here is 90 degrees. See? So there it is. You got this is 90 degrees. So this is the diameter. Let's call this D for diameter. And we don't know what these sides are. So we need to calculate diameter. So we will know it provided we know the other two sides of this right angle triangle. And then you can use Pythagoras to calculate D. See, I need to calculate diameter. The circumference of the circle is pi times diameter. So our goal is to work out pi times diameter. That's the problem. The problem, find the circumference of the circle. Right? And then after that, we'll be able to find what this n is. So I need to find the circumference. So to find the circumference, I need to find the diameter. Now let's see, what do we know about this A and B? Okay, they are congruent rectangles, so this has to be B, and this has to be A here. All right, and we are given that the area of this rectangle is 12. So the area of rectangle, we know the sides are A and B, so the area of the rectangle is length times breadth, and that is equal to 12, A times B. But we also know that the perimeter is 14. All right. Now, what is the perimeter? The perimeter of a rectangle is 2 into length plus breadth. That's the perimeter. But it's given that this is 14, so you have an equation. So you can calculate a plus b must be 7, right? And now by inspection, you can actually inspect and see, you can see what a and b are. In other words, which two numbers when added give you 7 and when multiplied gives you 12. You see, you have to think. Sometimes in mathematics, don't just barge your way through mathematics. At each stage, just understand what you are doing. You read this as, I got the sum of two numbers is 7 and this product is 12. So obviously the numbers are 3 and 4. So a and b are 3 and 4. So this is 3 squared plus 4 squared. That's 25. So d squared is 25. A and b are 3 and 4. So this is 25. D is 5. So the d is 5. So therefore the circumference is 5 pi. But 5 pi equals n pi. So n is 5. You see? So the only part here is here where you can actually, you are guessing the answer. You can see by inspection what a and b are. But you might want to calculate a and b by using equations and so on. That will take a little bit of time. You got two equations and two unknowns. One way is write a equals 7 minus b, and then you have substitute here, and you have one equation, one unknown, you can solve it. That's a way that you would do in school. You could get a trinomial or a quadratic equation and you solve that. You can do that. But I'm doing it by inspection, which is the fastest way. In this case, it works. But there is also another way, which is very interesting. You see, if you take a plus b all squared, what is that? That's a squared plus 2ab plus b squared. If you take a plus b all squared, you know that. So this is a plus b is 7. So this is 49. A squared. AB is 12. So you got 2 times 12, you got 24 here. And you got b squared. Now watch, you got a squared plus b squared. That's exactly what you're looking for. Right? We're looking for a squared plus b squared. All you have to do is to just subtract, put in 24 and put it on the other side, and you get your 25. And there we have it. You continue to work out what the circumference is like that. So that's an alternative way of doing it, solving this problem. Okay, so let's get to the next problem. I'm not going to ask you if you've got it or not, because we have quite a few problems to go through. Okay, let's have a look at the next problem. And this is another interesting problem. For how many positive integers k does the equation kx minus 12 equals 3k have an integer solution for x? So we need to find, you got an equation with two unknowns, k and x, but you're looking for integer solutions. What does it mean? It means you want k and x to be integers. It could be positive or negative integers. Right, so which integers will make this equation true? You can try some values for k and x and so on, right? And try to see what it works. But the best thing to do is to solve for one in terms of the other. And I can see I got two k's there. So let me bring the k's to one side. I've got k x minus 3k equals 12. Bring the k's to one side. And then I got k equals k into x minus 3 equals 12, right? And now let's look at the question again. For how many positive integers k? So this k is a positive integer. So k is 1, 2, 3, and so on. It's a positive integer. And you want this to be an integer, x to be an integer. So you got a positive integer times this, another integer, equals 12. So x minus 3 itself must be a positive integer. Positive. So x is greater or equal to 4. Those are the positive integers. So you got x greater or equal to 4, and you also have, so you got a product of two numbers equal to 12. Now you can actually write down what these numbers are, right? K and x minus 3. The product is equal to 12, so you can start with k is positive, so this is 1, and this has to be 12. K is 2, it has to be 6. K equals 3, 4. See, k is a factor, so you got k is 4, you have 3. You can't have 5, you can't have 6. 6 and 2, you can have 12 and 1. So those are the only positive factors of this. And in each of those cases, you will have an integer solution, right? You'll have an integer solution. Right. And so how many k's there are there? The answer is 1, 2, 3, 4, 6, 12. So there are six possible values for k. They ask you how many positive integers are there. The answer is you count how many there are, and there are 6 positive integers. So that's the answer. All right. So this is a nice problem because you are multiplying two integers to get an integer, and then you're talking about factors, you see? Right. That's what you mean by factoring integers. You don't say that, 2.5 is a factor of 12. Factors of 12 are whole numbers. So let's get on to the next problem. The next one is this one. Okay. So this problem says that you got a, b, and c are positive integers, and you got a funny looking thing here. You got 3 unknowns. Again, you got positive integers, but 3 unknowns and 1 equation. So how do you solve? How do you find what a, b, and c are? It's looking in a very, very funny way. Now, this is a very interesting problem. You'll see, and watch how we do it. If you haven't seen this before, then you wouldn't be able to do it. So watch the technique. Whenever you see some funny looking thing like this, a plus 1 over something, and that one is b plus 1 over something, then what you have to do is the following. Watch, you start with 30 over 13. Now you write this as a mixed fraction. This is 30 goes into 13 goes into 32 times 26, and remainder 4. So it's 2 and 4 13th, but I'm going to write that as 2 plus 4 13th. Now can you see? I got my a here now. A equals 2. Right. Right. Now, this 4 over 13 part, I've got 1 in the numerator. So you write this as 2 plus, write this as 1 over something. You can do that. It's 1 over 13 over 4. 1 over 13 over 4 is 4 over 13. So you look at your question, it's 1 over something. So you write 4 over 13 as 1 over something. And now you do the same thing for the 13 over 4 at the bottom, now we are here. So like what we did earlier on, you divide, 4 goes into 13, 3 times, right? 3 times 12, and the remainder is 1. So it's 3 1/4, but you can write that as 3 plus 1 1/4. And there you have it. You got your 1 over C. So your A and your B and your C are there staring at you in the face, and you need to calculate the sum of all these things, and the sum of those 3 numbers is 9. That's the answer to the problem. Okay, let me pause here after that long. Did anybody get 9? Did you work it out like that? 2 plus 3 plus 4. If you have, as I said, if you haven't seen the problem before, it's not easy to do it. You can do it by show of hands. If you look, you can go to the bottom of the screen and reaction. And press the reaction. All right, so now I can count how many people are raising their hands. I've got a fair number raising. You've got 62 participants. And we've got 24 people who've done it. Now that's very good, because I find it, when I saw this problem for the first time, I didn't know how to do it. So well done, guys. Okay, let's get back to this share. And now we're going to go to the next question. Okay, we're going to problem 15 now. Okay, problem 15, there's a kind of a long story there. If you read that story, what does it say? It says that a square tile is divided into 4 smaller squares. You can see it like this. Each small square must be painted using one of the colors, yellow, red, or blue. So there are 3 possible colors you can use to paint it. So you can paint each one of them. You can paint this as blue, yellow, red, blue, whatever it is. So you use 3 colors. You can paint them anyhow you like. But let's say, can you paint them anyhow you like? How many different tiles can be painted if exactly 2 colors are used per tile? Oh, in other words, only 2 colors are used. You're not allowed to use 3 colors. You're not allowed to use all 3. So you can only use 2 colors. All right, fair enough. And 2 tiles are considered the same if they can be rotated to look the same. Right? Now I'm going to show you the solution. But before that, let's see. Suppose I paint this. Oh, let's look at the solution. It's easiest. Okay, can you all see the screen? Hello?
Yes, Prof.
Yeah.
Yes, Prof. We can see the screen.
Okay, thank you. Thank you for that. Okay, so you can see these pictures here that I've drawn, and I was trying to work out all the possibilities, and what I did was I said, okay, let's just choose yellow and red. We'll ignore the blue for the time being. Let's choose yellow and red. So we have 2 colors, and in these cases, we have, I should have said, okay, suppose there's only 1 red. You can't have no reds, because you have to have 2 colors. Right? So suppose there's only 1 red. Let's look at this last diagram. There's 1 red, then you have 3 yellows. Now this is exactly the same as putting a red here and 3 yellows here, or a red here, or 3 yellows here, or a red here, 3, because it says that if you rotate them, right, you don't distinguish between those shapes. So those, all of them are exactly the same. Okay, so if only one red is shaded, then you will have this situation. Okay, this is one red. Now if you got 2 reds, now you can have 2 reds here, horizontal, but if you have this vertical, it's exactly the same, but you could have this situation. This is not the same as that. So this is another new possibility for 2 reds. And then you can have 3 reds. This is an example where you got 3 reds. So you can have either 1 red, 2 reds, or 3 reds. You can't have 4 reds, or you can't have 0 reds. So these are the only ways in which you can color if you're using 2 colors. Red, these 2 colors, red and yellow. So for that choice, I've got 4 ways of doing it. Now, if I choose red and blue, then there'll be another 4 for that. And if I choose that, oh, I've done something terrible. I'm drawing on my screen. Just hold on, please. Uh-oh. I drew this on my computer screen rather than on my tablet. Oh, God. All right, we're going to have that mess there all the time. Sorry. Okay, I'm not sure exactly what I did. So you got 4 for each pair. If I had Y and R, then you got 4 for that. For RB, you got 4 for that. And BY, you have 4 for that. So for different colors, and these are the only choices you have. If you choose 2 colors from those 3, so the answer is 4 times 3. The answer is 12. Okay, so let's get on to the next problem. The next one is problem number 16. Oh, I didn't write on the screen. It's come out. Okay. All right, problem number 16 is like this. What is the remainder when x to the power of 52 plus 201x over x is divided by x plus 1? Now, I've written detailed notes on this thing. So I'm just going to go through this. We can simplify this. It's x to the power of 52. Oh, I'm sorry, x to the power of 51 plus 201. Okay, this is x. You can cancel the x's. Right? So I don't know why they gave it like this. It's kind of a silly thing to do. So your thing is a polynomial now. This is a polynomial, but its degree is 51, right? And you're dividing this by x plus 1. So when you divide this by x plus 1, the question is, what is the remainder? Now, there is something in the syllabus, I don't know whether it's still in the syllabus. It's called the Remainder Theorem. And it goes like this. It says that if you take a polynomial, suppose we call it f of x, but this must be a polynomial. It can't be like sine of x or something. polynomial. And suppose you divide this polynomial by a linear thing. Let's call it x minus, we're going to write it as x minus a. Right. Now you can divide this, and you keep dividing and dividing and dividing until you get a remainder. Right? The remainder will just be a number, because you'll have to keep dividing until you just have a number. Because the moment you have anything in front of x, then you can still continue to divide. Okay, so this is the remainder. We'll call it r. There's a very easy way of actually calculating the remainder. The way to do that is you substitute this a into your function. When you replace the x in your polynomial by a, remember you're dividing by x minus a, then you will get the remainder. Very interesting fact. See, we can do an example to illustrate it. Suppose I take x minus 2. I'm going to do this quickly, and you get 2x squared minus 3x plus 4, right? How do you do this? X goes into 2x squared, 2x times. Then you get multiply 2x squared, you get minus 4x. Subtract minus 3x plus 4x is x plus 4, right? X goes into x one time. And then you say 1 times x minus 2. I don't know whether you know how to do long division. Now you subtract, the x goes away, 6. So there's the remainder. The remainder is 6. Right? Now, I said that you could have got the remainder by substituting x equals 2 into your polynomial. Now your polynomial is 2x squared, so it's 2 times 4 minus 3 times 2 plus 4. 2 times 4 is 8. 8 minus 6 is 2, and 2 plus 4 is 6. There it is. So you could have got the 6 by simply substituting there. So bearing that in mind, you can get the answer to this question. This is x plus 1, but it's the same as x minus 1, you see. So there you have to do a little juggling there. So then the a value is now negative 1. Let me just get rid of all the other things here. Okay, so when I'm dividing by this, the a value is negative 1. So to get the remainder, all I have to do is to substitute a equals negative 1 into this function. And when you substitute a equals negative 1, oh, this is 201, eh? Sorry, this is 201. And when you substitute negative 1, you get negative 1 to the power of 51 is negative 1, and 201 minus 1 is negative 1 plus 201, and the answer is 200. So that's the answer to the problem. That will be the remainder when you're dividing this thing by x plus 1. A very, very quick and easy way of finding the remainder. Otherwise, it'll take you a long time to go through this division process. Extremely long, because it's got a very, it's a highly qualified polynomial. The reason is it's got a very large, very high degree. Okay, let's just go on to this. Okay, I write some other notes here, so you could read through that when you get it. I hope you're looking at the Google class during the course of the week. How many of you are actually, I just want to see, how many of you are actually going and looking at the solutions that I put up and the recording? You know, I also put a full recording. Okay. Also, there are people who are looking at the solutions. Please, that's very nice. You must look at the solutions to get a proper understanding in case you didn't understand something. And I write some extra notes also in the solutions, which will be very useful, which I don't do in this class. All right. So the next problem is problem number 17. A sporting club has 100 members. All right. Of these 100 members, 44 play soccer, 45 play cricket, 50 play rugby, 8 play soccer and cricket only, 9 play rugby and cricket only, 7 play rugby. Now this is very complicated. 5 play neither soccer, cricket nor rugby. How many members play rugby only? Now this is a classic problem where you can draw a diagram to solve the problem. You call that diagram, I think we've done this last week. We had one simple diagram, but here this is a little bit more complicated because you've got a lot of information here. Here you've got 3 games. You've got soccer, cricket, and rugby, right? And you've got all kinds of information about how many people play soccer or they don't play soccer and so on. So we will draw 3 circles to represent the people who are playing soccer. We'll play one circle to represent the soccer players. Then you have another circle to represent the rugby players. Like that. And then you have a third circle to represent the cricket players. This thing is spawning. So, okay, let me just have a third circle to represent the cricket players. Maybe I better try it here. Okay. All right, this is not done very nicely, but what's happening here is that you've got various intersections like this. And if we say that I wonder why this thing can't be shifted. Normally we can shift it. I don't know why we can't shift the circle. All right, anyway. So you got cricket players, you got soccer players, and you got rugby players, and each one represents something there. So let's just write down soccer, S for soccer, C for cricket, and R for rugby. The rugby players form the small circle. Now, this picture will say the following. If I look at only this part here, any person here is inside the cricket, so he plays cricket. But he's outside the soccer one, so he does not play soccer. And he's outside the rugby one, so he does not play rugby. So all the people here play cricket, but they don't play the rugby and they don't play soccer. They play neither rugby nor soccer. They play only cricket. Right? And if you look at the people inside here, these guys, they play cricket and soccer. They're in both, but they don't play rugby. See? So like that, now you can go to each thing and you can see where this thing is and you can decide on whether they play cricket or rugby or soccer or they play both or whatever it is, all inside this diagram. But you will see there's one part here, anything here is in all 3. You see? The thing here is in cricket, it's also in rugby, and it's also in soccer. So these part here, there's one part there where all 3 people play all 3 games. Okay. All right. I'll go to my solution because everything is done there, and all these numbers, I can't keep track of them. So I'll go to my solution and we will explain what the solution looks like. So let's get to the next page. Right, so there's my solution. I know what I've got in the solution. I've got a big rectangle here because there is a school. And there are some people who don't play any of these, right? So we'll put the school as the outside thing. That means everything that is happening is inside the school. So this is the whole school population. And amongst them, you got the soccer and the rugby and the cricket players, as you can see, right? And all that information that we have, I'll put it down here so we can keep track of it. Now, the question is now, the actual question is, how many people play rugby only? All right, so the people who play rugby only are those here, right? So the way to do this is I start with those who play all three. It's always a nice place to start, where people play all three, okay? If you had two sets, you look at you'll give a name to those who are in both of them, the intersection, what you call the intersection. So suppose the X who play all three. All right. Now, it is given here that let's look at this part here. 8 plays soccer and cricket only. So you got soccer and cricket. So here you got this part here. Those are the people who play soccer and cricket, but they play soccer and cricket only. So they don't play rugby. So they're inside here, but they're not inside here. That's why I put an 8 here. See? So these people, where I'm tracing this, they play soccer and cricket, right? But they play soccer and cricket only. They don't play rugby. So you can't be inside the rugby set. So you're outside it, but inside this thing here. So that part is 8. So like that, you can get 7 and 9 there as well. The 9 and the 7 take care of that. Okay. So now we have 7 and X and 8. And we also know that 44 people play soccer altogether. So altogether into the circle here, you got 44. If you add up all these different numbers, you're going to get 44. All right. But you already know 3 of them, 7, X, and 8. So to work out the part which is outside here, you have to say it's 44. Altogether, you got 44 in this whole soccer set. But to work out what's in this part here, the people who play soccer only, you have to remove these 3 numbers. And those 3 add up to 7 plus X plus 8. 7 plus X plus 8. And then when you work this out, 7 plus 8 is 15. 44 minus 15 is 29. And then minus X. So you have 44 minus 7 minus X minus 8. And that's how I got 29 minus X. See? Like that, I got 34 minus X here. And I got 28 minus X. If you do the same thing with the rugby, you know how many people play rugby altogether. You also know how many people play cricket altogether. And in each case, you can calculate what's in these things. So the number of people who play rugby only, that's our question. Right? We are looking for 34 minus X. These are the people who play rugby only. They don't play neither soccer nor cricket. They're outside that set. So we need to find what 34 minus X is. And to do that, we need to calculate X. So the X is the unknown. But now they say that 5 play neither soccer, you can't say use neither. The 5 play none of soccer, cricket, and rugby. So that means there are only 5 people outside the set. These people who are outside, are the people who play none of these 3 things. So there are 5 people outside. But you must remember, you were told that there are 100 children altogether in this school. So it means that if I add up all these quantities here, together with the 5, I'm going to get 100. So there it is. You're going to get an equation now because there are 5 outside and everything inside here. We got it in terms of x. Add everything, simplify with all the x's and so on, and you get a kind of complicated equation. A lot of terms in it. I'll show you what it is. So we write all these things down and you can solve for x. See, you can add up everything inside and that is equal to 100 because this is the total number of children in the school. The 5 were outside and you can see these numbers were in those different sets. And when you get x, you solve for it and you get x equals 10. Right? That's a simple thing to solve. And remember, we're trying to work out how many people play rugby. Only now we know the value of x. So therefore, we should be able to calculate 34 minus x. And the answer is 34 minus 10 because we said x is 10. And the answer is 24. All right. So the answer to that problem is 24. Let me just, out of curiosity, to find out how many of you actually got 24. So I have 64 people in the class. And all right. It's quite an intense problem. So those people who have done it, they're probably in grade 12 and they've seen Venn diagrams. And these are called Venn diagrams, these circle diagrams. So they are more comfortable with this kind of problem. But you can see it's not so difficult. Just draw circles and just decide what the intersections are in terms of the context. All right, thank you very much for that. We're going to continue to get to the next problem, which is number 18. How many odd positive integers, the sum of whose digits is 4? So they are odd numbers, and when you add the digits, you're going to get 4. The question is, how many such this thing is playing up again. All right. So you got a number. When you add the digits, you're going to get 4, right? We are looking at only those digits. And also we are looking at those which are odd. And then we want to know how many of those are not prime numbers. So you have to ask yourself, what are the numbers? All right. The only thing we know about them is when you add them, you can get 4. But none of the digits are 0, so we must not put 0 in it. All right. So you got, when you're adding the numbers, you can, let's start with, you can have all, okay. You can have 0 ones. Well, let's start this way. Suppose you could have 4 ones. That's the extreme case, adding to 4. 4 ones. Or you could have 3 ones. But you can't have 3 ones because you've got 3 ones. The next one will have to be a 1 as well. So it's not possible to have 3 ones, exactly 3 ones, because they're adding up to 4, you see. So the next one will still have to be 1. Okay, so you could have 2 ones. Let's try the 2 ones. You could have 1, 1, and then the last one will have to be 2. So the 2 can be in front, or you could have 2 in the middle, or you could have 2 at the end. All of them have got exactly 2 ones, and 1, 2, obviously. The remaining number will have to be 2. Or you could have 1, 1, right? And then you know, 1, 1, and then the other numbers will add up to 3. So you could have 1, 3. I mean, they add up to 4. So the remaining part will have to add up to 4. And you could have 1, 3, or 3, 1. So you have to have 1, 3, or 3, 1. You finished with 2 1s and 1 2. So these are the only ones which have sum 4. These are all the sum 4 numbers. Right. So we finished with that. The sum of the digits is 4. But we didn't say they must be odd. Right? Okay, so this is acceptable, that is acceptable, that is acceptable, but this is not acceptable. That's not odd. So you got the 5 possibilities. And you want the numbers, the third one is they must not be prime. Right? So you have to remove all the prime numbers now. 31 is a prime number, so that has to be removed. They are not prime. So here too, this has to be removed. So you're left with only 3 things. This you can't remove because it is not a prime number. It's 11 times 11. And this one also, you can see clearly that 11 goes into this. Right? So you can't remove this. But what about this? Now we don't know, is this prime? Okay, it's a kind of big number and you're not allowed to use calculators. So you have to check to see whether this is prime. Now you have to go through. The way to do that is to try all the prime factors. Well, obviously, you start with 3. 3 is out because the sum of these numbers is 4. Right? The next prime number is 5. You can eliminate that. You can try 7, but 7 certainly doesn't go into that. So 7 is out. The next prime number is 11. When you try 11 here, you will see 11 doesn't go into that as well. So that's out. And then the next one is 13. You try 13. Okay, now that will take a little bit of time, but you will see even that is out. 13 doesn't go into that. And that's as far as you will go, because when you go to anything beyond, you will have something which is smaller. If you try 17, you'll see the other factor will be smaller than 13, but we've already taken care of all the numbers which are smaller than 13. Okay, if you don't understand that, you must go to my lesson 1 in my notes, in my book, and there you will have a good idea as to how to factorize numbers. So this is a prime. None of the numbers, not that one, this one here, it's a prime. All right, so you have to remove that. So the only ones which survive are 1, 1, 1, 1 and 1, 2, 1. So the answer is, the question is how many odd integers? And the answer is 2. There are only 2 such numbers. They're not asking for what they are. They want to know how many are there. So the answer is 2. Okay, so that's problem 18. Problem 19. Problem 19, it says that AB is a geometry problem. AB is a diameter of a circle with center M. The diagram is given, so we can have a look at that diagram. So AB is a diameter of a circle. So there it is. That's the diameter. And there's M is a center, right? Chord CD, this is a chord. A chord is a line that joins 2 points of the circumference. So CD is a chord, but it's parallel to AB. So this information is not listed here. It's parallel to this, right? And then AC equals EC. So from C, AC equals CE. These two are equal. So this little triangle here is isosceles, and CA is equal to CE. So just remember that this is an isosceles triangle, these are parallel, and this is the diameter. That's important, this is the diameter. The question is find angle CAM. CAM in degrees. Well, obviously you have to find it in degrees. So this is the angle that you need to find, this angle here. That's the question. Now the thing about this problem is that you have to use the fact that it's a diameter And you have to use the fact that this is the center of the circle, right? And when you try to do it as it stands, you'll find it very difficult to do it. I'm not sure whether it's even possible. So you have to have a construction in this one. The question is now, what should be the construction? A possible construction is, remember I told you earlier on, a diameter, when you got a point on the circumference, when I join A, D, and B, I'm going to get a 90 degrees here. So that's another useful piece of information. So you can join D and B and you get 90 degrees, and that will help us to solve the problem. Or you can, there's another radius here which is undone, MD, we can join that as well, right? And try to solve that problem. Then we have an extra line here. In fact, that'll give you lots of isosceles triangles also. So that'll give you a lot of armor, a lot of weapons to move forward. You've got lots of isosceles triangles, and you can say base angles are equal. All right, so those are two possible constructions you can do. And I'm going to go to my solution so I don't have to draw this thing. There are some other things that I say along the way, which are about circles. The thing is, that many of you are in grade 10, so you might not have done circles. I've got some facts about circles in the previous slide, which I'm skipping. This is the problem where I told you, if you join the diameter, right, and I give a name to this acute angle here that I'm pointing to, X. The reason I got a parallel line, you see. So if I start with this, I got alternate angles. So that'll help me a bit. So you got a starting point. And you got other isosceles triangles here. And then we don't know what this angle is. So we give a name to that, because we also know that this is isosceles. So you give a name to that one, right? And these two will be the same. I've got the red lines are equal, right? So these two will be the same. And then you calculate the other angles in this picture, right? I'm not going to, thank you. I'm not going to tell you why. You can go and have a look at the picture and try to figure out why this is X plus Y and why that is Y minus X, right? In this picture. And it'll be an interesting exercise for you to do. And then eventually you got two unknowns, X and Y, and you can solve this using two unknowns, two equations and two unknowns. You see, that's a nice thing about using symbols in geometry. I always use X's and Y's for unknowns. I don't use A1 and D1 and C1 and all that like the way they do in school, because you can't get equations. To get equations, I use X's and Y's, and then you can solve. You see, and very often in school mathematics they don't want to use X's and Y's. I can't understand why. All right, but now the one that I'm going to do is you can do it like that, but I'm going to give you another solution. That is why I rushed through this, because I'm going to do this last solution. And here, this is the one where I said, let's join M and D. Okay, I'm going to open this thing up so that all of you can communicate with me. Oh no, you can communicate with me. So you can open up your mics and you can talk to me, and I'm going to ask you some questions. I'm going to calculate CAM from this figure, all right? And I'm going to start with this angle here, X. All right. Name me another angle or more angle which are equal to X in this picture.
ADC.
ADC. Right. Somebody can tell me why those two angles are equal?
Alternative angles are equal. CD is
Right, very
parallel
good.
to AB.
Right. Any other angles which are equal to x in this figure?
ADM.
ADM. And what's the reason for that?
Because AM and MD are equal, making
That's right,
them.
they are radii. Very good. The M is the center of the circle. So you've got, these are radii. So you got that. Now you got this whole angle here.
MCD is equal to 2x.
MCD is 2x because this angle is 2x. And these are still radii. So this will be 2x. Right? I'll be moving now. If this is 2x, what can we say?
CMD is equal to 180 minus 4x.
Or I can avoid the 180 minus. There's another angle which is equal to 2x.
CBA.
Which one? C?
CBA.
CDA.
B.
Oh, CDB. You think this is 2x?
CBA.
Come again?
CBA.
I can't hear you, sir.
They said DBA.
DBA. Oh, I see DBA. Eh? Oh, why do you say DBA? I haven't joined that. So let's not get into that. Let's not get into that area. They are parallel lines, so you got alternate angles, right?
I was
CMA.
here the whole entire time. I think so.
So CMA. You agree, CMA?
Yes.
These are alternate
CMA.
angles. In fact, even these are this alternate to this. This is 2x, yeah? So there's your z. But let's just move on this side here because I want to use the fact that, remember, we said that these two are equal. Okay? So you got an x here and you got a 2x. Can you see I've got these are exterior angle. I got a flag here. X plus 2x is that one there. Agreed? This angle here. It's the exterior angle of the small guy, AEM. Exterior angle is equal to the sum of the interior opposite angles. So x plus 2x is that, 3x. Do you all see that? Okay. Which other angle is, how can we proceed now?
CAD is also 3.
CAD is 3x.
CAD is 3x, right?
DEM is 3x.
DEM, yeah, okay. They are vertically opposite angles. Okay, I'm not going to put it in. Now watch, MC and MA are also radii, right?
ACM is
ACM, what is ACM?
4x.
4x. Now I've got enough material because this angle plus this angle is 180 degrees. They are co-interior angles. Parallel lines. So this whole angle is 6x. This angle is 4x. 6x plus 4x is 10x. And the sum of these two is 180 degrees. Therefore, x is 18. And we wanted CAM, and that is 4x. And that's 4 times 18. I think it's a very, very nice problem. The reason why I'm saying it's a very nice problem is that no angles are given. The problem doesn't tell you any angle in this picture. Usually they'll give you this angle or that angle, then you can calculate. But no angles are given at all. And yet you can calculate. all the angles, right? In fact, you can calculate all the angles. Because now you got everything, so many x's here, you know what x is, so therefore you should be able to calculate every angle in sight. All right. So we didn't use anything higher than, we didn't even use that angle in a semicircle is 90 degrees in this, only isosceles triangle. So it's I like the solution. It uses very simple techniques. Okay, let's go on now. Let's get to the next problem. The next problem is, okay, you can switch your mics off now, please. Now, in this problem here, you got two parallelograms with perpendicular heights 5 and 10, respectively, overlap at an angle of 30 degrees as shown. So you got these funny shapes, but they're parallelograms and they kind of overlap. And the question is, determine the area of the overlap. It's shaded. Now, this looks a little bit complicated. You see, you've got parallelograms. The height is a perpendicular height. And there's a very important function that a height of a parallelogram has. Namely, you can find the area. The area of a triangle, a parallelogram, is base times height. So area of any triangle, area of a parallelogram is base times height. And the area of a triangle is half base times height. So if I were to work out the area of this triangle here, it'll be half base times height. Right. So you got two important formulae, the area of a parallelogram and the area of a triangle. So now we've got two heights are given here. Right. It's not very easy to see it, but if you look at this parallelogram here, the yellow one, you can find, the question is to find the area of the yellow one. So that area is, if I to take this as base, right? Then the height will be 5. But if I take this as base, the height will be the perpendicular, these are parallel lines. The height will be the perpendicular distance between this parallel line and that parallel line, and then that'll be 10. All right, so that's a piece of information that you have. But another interesting thing is that they do say that this angle here is 30 degrees. And if you look at this picture here, you got 30 degrees here, and the height is 5. So if I actually watch now, you can observe, if you observe this, watch, you got a right angle triangle here. With the height equal to 5 and an angle equal to 30 degrees, right? And if you got a right angle triangle with an angle and a side, they could calculate everything in sight, all the angles and all the sides, right? Now this is really grade 9 trigonometry. So those in grade 10 would be hard pressed. So I can actually calculate AB because I will have that 5 that's known over AB. We need AB because AB is a side of the yellow of the parallelogram. So AB is a useful thing to calculate. That's equal to the sine of 30 degrees opposite over hypotenuse. Right? But all of you should know what sine of 30 degrees is. That's half. So there you have it. You got 5 over AB is equal to half. So what must AB be? AB is then 10. So we know what AB is. AB is 10. So this thing here is 10. Oh, but now I got this. I got one base of this yellow parallelogram, and also know the height. So the base is 10, the height is 10, and therefore its area is base times height. So the area of the yellow parallelogram is 100. So the thing is, you have the height here, and you have the base times height is 100. So the idea was to actually focus on this base here to work out the parallelogram, right? Area of the parallelogram. And that base you can calculate what it is because it's part of a right angle triangle. Okay, so the next problem, we go on to the next problem. I wonder if anybody got this problem out. How many of you got this? 100. Okay, we have some pretty sharp guys here because that's not an easy problem as well. Okay, so I can expect a number of you to get into round 3. Right, now the next problem that we are going to look at is this one. Here you got a loaded truck travels from Durban to Pietermaritzburg at an average speed of 60 kilometers per hour. And after unloading, returns by the same route at an average speed of 90 kilometers per hour. What is the average speed of the truck for the whole journey? Now, this is a trap question. The question is, so what is the it's for the journey now. So you're not worried about what happened when it's in Pietermaritzburg and it's unloading. You just want to know while it's traveling, what is the average speed? The natural inclination would be to say, well, you got 60 up, 90 down, and therefore the average speed is 150 divided by 2, which is 75. It turns out that that is not the answer to the question. So it's something that people can easily make a mistake with. Now, why? Why isn't this the answer to the question? Okay, just suppose you're working with Durban and Pietermaritzburg. We don't know what the distance is. Suppose we call that distance D. All right. Okay, it's traveling from Durban to Pietermaritzburg at 60 k's, and from Pietermaritzburg to Durban, it's 90 k's. 90 k's per hour. Right. If you want to find the average speed of the truck for the whole journey, you have to work out the total distance it travels over the total time it takes. That is where the confusion comes, right? The total distance that it travels is D plus D. So the average speed will be the total distance over the total time that it takes to cover that distance. Right, now the total time will be the the time from Durban to Pietermaritzburg, which is traveling a distance d at speed 60. So the time that it takes will be d over 60, distance over speed. Speed times time is distance. And the time it takes on the down journey from Pietermaritzburg to Durban. I live in Durban, so this is the down journey, we call it. But there is still traveling the same distance, but this time it'll take a shorter time because it's traveling at 90 km per hour, and it'll be d divided by 90. So the total time that it takes is that, and that is the average speed. This is what you're looking for. Total distance over total time. And you'll notice that the d's actually cancel, right? I'm not going to work this thing out. This is, after this is just a matter of technique. Let's see what the answer says. It turns out so this is what I've got, and if I can multiply on both sides by 180, that's the LCM. That's a nice way of getting rid of fractions. Multiply by the LCM, but this is a fraction, so you multiply numerator and denominator by that, and the d's cancel, and you got 3 plus 2 is 5. These cancel. 5 goes into this 36 times, so it's 36 times 2, which is 72. I told you that when you got fractions, you cancel. That's the best way to do it. Don't multiply everything. It takes you can save a lot of time. So the answer is 72, not 75, as you might have suspected. Okay, so let's get on to the next problem. Number 22. Now, number 22, the problem, now this is quite a hard problem, but actually when you know the solution, you'll see it's not hard at all. Let's read this thing. The roots of this is a cubic polynomial. The roots, that means the solutions of this equation. It's got degree 3, so there are 3 solutions to this. So there are 3 solutions to this. And how do you find the 3 solutions? You have to factorize this. Like how you find, if I find a solution of a quadratic, factorize it and make this equal to 0, make that equal to 0, and you get the solutions. So that's the way to do it. So I need to factorize this. But they are in arithmetic progression. Now that is, which makes the problem a little bit difficult. When I'm factorizing this, I should get 3 factors because you got a cubic. The last numbers multiply to 15. In fact, the last numbers multiply to minus 15. Now the fact that they are in arithmetic progression, that should help us. You're multiplying 3 numbers to get 15, and they're in arithmetic progression. So evidently it's going to be 1, 3, and 5, isn't it? That's a good choice. So all this is guessing. And then you need to have all minuses. That's a constant term, will be minus 15. Now here, these first 3 multiplied will give you 64x cubed. Now you want 3 numbers. When multiplied, it gives you 64x cubed. So they should be, 64 is 4x, 4 cubed. So now, when you got this, if you work out the roots, make this equal to 0, you have a quarter. Make this equal to 0, 3 quarters. Make this equal to 0, 5 quarters. right? So, and if you look at it, you'll see they are the roots of this polynomial, and at the same time, they are in arithmetic progression because you're adding 2 over 4 each time. 2 over 4 plus that gives you this. 2 over 4 gives you this. They are in arithmetic progression. The only thing is you don't know about the 144 and 92 because all this is a guess. So you have to multiply this thing out. And when you multiply the whole thing out, you got 3 things multiplied out, you will get this. It actually turns out to be exactly the same polynomial. So whatever this guess was, it's correct. Right? So these are the 3 roots. And the question is, what is the difference between the smallest and the largest? The smallest is a quarter, the largest, and the difference between the smallest and the largest is 5 over 4 minus 1 over 4, and that's 4 over 4. And that's the answer to that problem. Okay, it's a kind of it's a problem where you have to use your intuition and guessing and so on, right? And it's and it makes it looks as if it's very difficult, but if you try to use some common sense, you'll find that it's not that difficult at all. Okay, now let's just get on to what happened here. All right, problem number 23. Problem number 23 looks a little bit weird because you got something involving a function of n, right? Here, this is n plus 3. That means you're substituting n plus 3 into the function. Here, you're substituting n into the function to get the value. And here, you're substituting n. And you got some equation involving these things. And they say, determine the value of this thing. They give you only one piece of information, namely f of 3. And they ask you, how do you calculate that? So this looks like a very difficult problem. Okay, I'm going to just see whether I can calculate some values. I know the starting point, f of 3, I know. So when I put n equals 3, I know the value. Right, so I know f of 3. So I know f of 3 here. So why don't we put f of 3 minus 1 over f of 3 plus 1. Put n equals 3 here because I know f of 3. But then the left-hand side becomes, n equals 3 becomes f of 6. Now we know what this is. It's f of 6 equals, f of 3 is 3. So this is 3 minus 1 over 3 plus 1. That is 2 over 4. And that's a half. So now we know f of 6. You see, f of 6 is a half. All right, now I can continue to do the same kind of a thing. Now I know f of 6. So I can substitute n equals 6. Okay. Put n equals 6 here. F of 6 minus 1 over f of 6 plus 1 equals n equals 6. So this becomes f of 9. Now, I'm working on f of 3, f of 6. I need to get to that one. So what I'm doing now is trying to look for a pattern. Okay, f of 6. Now what is f of 6? We said it's a half. There's a half minus 1 over half plus 1. Right. I will multiply numerator and denominator by 2. I like to get rid of fractions. Don't work with fractions. Multiply, but in a fraction, I multiply both of them by 2. The fraction doesn't change. So you have 1 minus 2 over 1 plus 2. If you multiply the denominator by 2, and 1 minus 2 is negative 1, and 1 plus 2 is 3. So f of 9 is a third, or minus 1/3. Right, now I'm going to stop there because I'll get into my own solution to tell you how this is going. We can save some time. So I've given you the starting points. You see, if you look at this, f of 3 is 3, and we calculated all these, right? Now when you calculate f of 12, you're going to get negative 2. And when you calculate f of 15, you get 3. Now that is an interesting thing, because when you started with f of 3 is equal to 3, and f of 15 is also 3. So you're going you're going to start doing the same thing. You're going to go repeat. When you work out the next one, it's going to be a half. And you're going to work, the next one is going to be a minus third. And the next one is minus 2, and so on. So what's happening here is that these numbers, 3, 6, 9, 12, 15, 18, and so on. These are your n values. And the f of n, right, is equal to a half. No, I'm sorry, it starts with 3. 3, half, minus the third, minus 2, and 3 again. So 3, f of 3 is 3, f of 15 is 3. The next time it's 3 is at 27. That's 12 away from 3. They are the same. So 12 away from 15, they should be the same. So f of 27 is also 3. So if you keep adding 12, f of 3 plus 12, and then you add another 12, 3 plus 24. So what we are saying here is f of 3 plus 12 times a number is always going to be equal to 3. See? Because you're adding 12 each time. 3 plus 12 n equals 1. 3 plus 12 plus 12, that's your 27. The 2 12s. So this is always going to be equal to 3. So that's very useful. Now you know that you can put any value you like for n, is going to be 3. Now if you try to look at 2019, I want to say now how many 12s there are in this. And to do that, you divide. So when you divide 2019 by 12, you actually get 12 times, I think you get 168 plus 3. So 2019 is actually 12 times something plus 3. Now that's very nice, because whenever you got 12 times anything plus 3, the answer is 3. So already we know that the f of 2019, this must be 3. See? And we are asked to calculate this thing here, simply add 19 to it. So 3 plus 19 is 22. So this quantity here is 22. So the idea is to look for a pattern, and the pattern here is, it's what you call a cyclic thing. 3, half, minus a third, minus 2, 3, half, minus a third, minus 2, 3, minus half, 1 half, minus, it just keeps going like that in a cyclic fashion. And then whenever you have that, then you can predict exactly what is at any given number. But you have to you have to think about it and see how do you do that. Right. All right, so the next problem now is where I'm going to look at problem number 24. Well, actually, I'm not going to look at problem number 24. I'll tell you why. This is a very hard problem. Look, when you do this, you get some very, very complicated formulae and all that. So I'm not going to spend time on that. When you get it, when you get the solutions, you can try to read it and see whether you understand it. If you understand it, well and good. If you don't bother about it. It's a hard problem. It's the kind of problem which they should have asked in round 3, not in round 2. Okay. So you got problem number 25. This is the last problem of 2019. It says squares. Let's have a look at the squares. S and T are each placed outside a square of side A. So you got a square of side A, and then you kind of extend that to get another square inside a square of side B, right? And then when you take the square of side A and you take the square of side B, you draw another little square in the corner here, and that square is S. Then what you do is the sides of square S are parallel to the sides of the other two squares. Okay, that's fine. But on the diagonal of square T, and there's another square here. But the diagonals of the square T, right? Let me just draw the diagonals and just see what's going on here. So this diagonal there, the diagonals of square T are parallel to the sides of the other two squares. So these are horizontal and vertical, just like all the others, right? So that's the property of this square. But you'll notice that square, it goes through this corner here, and it touches these two sides also. And the question is now, if the side length of square is 27, of square S, so it's given that the side length of square S is 27, it means that this one here is 27, right? What is the area of the square here? Okay, this thing requires there's a lot of geometry involved here, but also a lot of intuition, which I don't like doing. So I've got quite a few proofs, quite a few calculations. I'm not going to go through all those calculations. When you get the notes, you can study it, but just remember that you've got the original square is 27, and you want to find the area of the square here. So what I do is, evidently A and B don't feature in this thing here because you want to know what the area of this is. So the action is taking place all here in the corner. Right? So what I do is I just draw just that part, the corner, and see what's going on there. I don't bother about the bigger picture. And you can see I've drawn the corner part. But I put them together now. You see, there were two diagrams. I got the first diagram at a square like this. Second diagram at this tilted square. And we knew that this diagonal is going to be parallel to these two sides. See? Likewise, this diagonal here is parallel to these two sides. Okay. So if you actually draw the diagonals of these squares, I'm going to just draw it for the time being. if I draw the two diagonals, you will see that this is 45 degrees, you see. The diagonals of a square, they bisect each other at 45 degrees. So this angle here is 45. So therefore this will have to be 45. So you got all these angles of 45 degrees like this. And, but the thing is, this point here, we don't know where it is. Okay. So what I do is actually, through this point here, I complete this square. You see the square here? These 4 points are points on the sides of another square. And I draw that square. So I draw this larger square. Okay. And let me just remove my, I've gathered that this is 45 degrees. So we'll just remember it's 45 degrees. I'm going to take these diagonals out. But I've drawn this large square. Okay, now you can draw. It turns out that this part from here to here is the same as this part, right? So what happens is, what I do is now I break up this original square into 16 parts. You will see, or the new square into 16 parts. You notice I got them in very light lines. I don't know whether you can see it. Can you see these lines here? Is it visible? No?
Yes,
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 Prof.
yes.
Oh, it is visible. All right, so what I've done is this large square here, right? Because these are equal. Now, I made all these three equal like this. And then the large square divided into 16 equal parts, right? So the area of the large square is 15 times the area of each of the small squares. So let's just take these things out. So we say, suppose the area of each of the small squares here, this one here. So I'll break it up into smaller units. We've done something like this last week. When you break it up into smaller units, you have a better idea as to what the area is. So the area of the large square is 16 times the area of each of the small squares. But remember, if you recall, we were given that the sides of that original square, we were given that. So let's just bear that in mind. The side of the original square, this is the original square. Right in the corner, it was stuck there, right? So that was 27. This one here. Okay. So it means that each of these is 9. So therefore, each of these, the area of each area here is 81. The area of every small square is 81 because the area of this thing there is, the side is 27. They're split in 3 equal parts. So this is 9, that will be 9. So your x, which are called the area of the small square, this x is actually equal to 81. Right. Now, the problem is to find the area of this tilted square. That is the problem. You can find it because you find the area of the large square minus these 4 corners. You snip those corners off, you will get the area of the square here under investigation, right? The area of the large square is 16x, because there are 16 small squares. So the area of the large square is 16 of the small squares, and each small square is 81. And now this part here, what is the area of this? If you look carefully, you see the area of this is really half base times height, the triangle, and the base is 2, the height is 2, 2 times 2 is 4, and half of that is 2. So the area of this is 2 square units. See? And each square unit is 81. So the area of this is 2 square units. This will also be 2, this will also be 2, this will also be 2. So you have 8 square units. Right? The 4 areas which you snip off from the corners of the original square, the large square, if you take them off, that will give you the area of the square that you're looking for. So when you calculate this one here, 16 times 81 minus 8 times 81 is 81 into 16 minus 8. See, you use mathematics to simplify. 81 times 8 is 648. So that's the area that we're looking for. And now I've given another solution. I want to go over that solution, which I think is a very interesting solution, a very intriguing solution. It's a very powerful method of solving a problem. And it uses analytical geometry, believe it or not. So I'm going to give you a very interesting solution which uses analytical geometry to solve this problem. I'm going to explain it because I've got the diagram here and I'm going to explain this diagram. I hope you can all see this. It's kind of small. Now I've drawn that part under investigation. I've drawn it here, as you see. Just one moment, please. I must have my hot drink at 10 o'clock. My wife knows that I die without it, so she brought it. Thank you for waiting. Now, the interesting thing about this thing here is that if I know this point here, which I'm pointing to, then I can draw the entire square. All I have to do is to remember we had 45 degrees here. So I tilt this thing at 45 degrees and then put another 45 degrees here, and then where it meets, we complete the square. So all I need to know is this point here. I know that point. Now what I do is, now this is where the analytical geometry comes in. I choose a set of axes here at this point here. You see, remember this is we had this is 27, 27, 27, 27. So choose the origin at this place, at this point, and then you got quite a few coordinates you know. So I draw y-axis and an x-axis like that, and then now I use coordinate geometry. See, we originally we had this is 27 and that is 27, so the coordinates of this are 27, 27. Remember, this is the origin, right? Now here, this is parallel to the x-axis, so the y-coordinate is 27. And the x-coordinate we don't know. If I know the x-coordinate, I can work out everything else. So let's give a name to it. I'm calling it A. So this point here is a point whose coordinates are A and 27. Now, this point here, if I join it to the origin, I have a line which makes 45 degrees because it's the diagonal of a square. So the equation of the line is y equals x. Now, it's a very interesting fact that when you so this point here, now watch, this point is a reflection, R is a reflection of Q across this dotted line. R is a reflection of Q across this dotted line. This thing here is 90 degrees. They cross each other at 90 degrees, and these are equal. So therefore, this is a reflection. Right? And whenever you take a point and reflect it across the line y equals x, the coordinates change. They switch. Now, what do you mean by that? I've drawn a diagram here to explain what I'm doing. When you take, there's your line y equals x, and I take any point and I reflect it. It means I join this line here is perpendicular, they're equal, and I get to this point. Now I don't know what these are, what this is yet, but just watch. I want to know, given this point, what is this? I wrote down BA. Now where did I get that from? Well, this point is coordinates are A and B, so this thing here is A, and that one there is B, because the coordinates of this are A and B. And if this angle here is theta, see now this, if you look at from here now, right, you must have that this angle here is also theta. You see, these two triangles are congruent here. These are equal. These are equal. So this red triangle is congruent to that triangle. Okay, and therefore this part here will have to be B, and that part there has to be A. They're congruent, right? And that is why the coordinates here become BA. So it's an interesting fact that when you take a point and reflect it across the line y equals x, then the new reflected point, all you have to do is to just switch the coordinates to get to that. Okay, now we're going to use that fact here now to solve this problem. I'll go back to my earlier diagram. So when I reflect this thing across, this is y equals x, R, the coordinates for R are 27A, right? I'm trying to calculate A now. If I know A, then I can solve the problem. Now, if you look at P, this thing here is, this line here is parallel. And these are equal. And they are diagonals of a square. They are perpendicular to each other. And this is the other point across this thing. So this point here is, this point is a reflection of this across that line. But what's important is that the y coordinates still remain the same because this is parallel to this. So y coordinate of this is A, but what is the x coordinate? Now, this line here goes through the origin, but it's got negative gradient. The negative gradient of this is actually -1, right? The gradient of this line here times the gradient of this is minus 1. They are perpendicular to each other. So therefore, the gradient of this is minus 1. And therefore, the equation of this line is y equals minus x. So if the y coordinate was a, then the x coordinate will have to be minus a, because the y coordinate is always the negative of the first one anywhere along this line, right? So now we can actually have an equation, because we know the gradient of this line here. The gradient of the line is the same as the gradient of this. The sides of the square are parallel to this, remember. So this gradient is plus 1, but the formula for the gradient is y2 minus y1 over x2 minus x1. So you'll see, I calculate the formula for the gradient. It's equal to 1. That gives me the value of a. I got an equation using the gradient formula. A equals 9. And then if a is equal to 9, then I can calculate the area of this. Now, what is the area? The area of this square that we're looking for is the side squared. So the area is PQ squared. So now you know the coordinates here. So we can use coordinate geometry again. PQ squared is equal to x1 minus x2 squared plus y1 minus y2 squared. So you can subtract these two. Okay, it's actually supposed to be something else. I'll correct this thing. So you do that, and then you substitute the value for a into that, right? You know the a is equal to 9. If you want, you can put 927 straight away, minus 9 plus 9, just substitute, and then you can now calculate PQ squared, and that is the area. So that is how you do this using coordinates geometry. In fact, I have some other solutions as well. This is the last problem of 2018. So it is quite a difficult problem. But the very first solution I gave you is the easiest one.